Welcome back to Hypothesis Testing Done Right, Part 6 of 14. In Part 5, we define size and power and the four levers that move them. But power stays abstract until you compute it. So in this part, we do exactly that. We work out how often Sam's test would actually catch a real edge, and the answer explains why a short back test proves so little. Suppose the reversal rule's true edge is 5 basis points per day, with a standard deviation of 75 basis points. Over 252 days, the standard error is about 0.0473%, so the true mean sits 5 basis points over that standard error. About 1.06 standard errors above 0. The rejection rule one-sided at alpha equals 0.05 fires when t exceeds 1.65. The probability of that, given the true mean, is the chance a normal centered at 1.06 exceeds 1.65. That is, the probability a standard normal exceeds 1.65 minus 1.06, which is 0.59. That probability is about 0.28. So a rule with a genuine 5 basis point daily edge would be detected only about 28% of the time in a single year of data. That is low power, nearly 3 times in 4. A real edge this size would slip past Sam's test unnoticed. The metal detector is sitting on treasure and staying silent. How much data would Sam need to fix this? To reach 80% power for the same effect with this one-sided test, the true mean would have to sit about 2.485 standard errors above 0, that is, the critical value, 1.645 plus the 80% margin of 0.84. Working backward through the standard error, that requires roughly 1,390 days of data, about 5.5 years. And if Sam insists on a two-sided test instead, the bar rises to 1.96 plus 0.84, about 2.8 standard errors, pushing the requirement to roughly 1,760 days, about 7 years. This is exactly the kind of arithmetic a power analysis produces before you commit to a study. And it explains why a non-rejection from a short backtest proves so little. Now, Sam's actual t of 1.69 does exceed the one-sided critical value of 1.65, so the rule clears the alpha equals 0.05 bar, but barely. Before celebrating, notice how marginal barely is, and ask the question we have been deferring: exactly how surprising is 1.69? To summarize Part 6, power becomes real only when you compute it. For Sam, a genuine 5 basis point daily edge would be detected only about 28% of the time in a single year, nearly 3 chances in 4 that a real signal slips past. To reach the conventional 80% power for that same effect would take about 1,390 days, roughly 5.5 years, and a two-sided test would push that to about 7 years. The lesson is that a quiet backtest, one that fails to reject, proves almost nothing when power is this low. Sam's t of 1.69 does clear the one-sided bar of 1.65, but only just. In Part 7, we examine the choice that set that bar in the first place, which tail the rejection region sits in, one-sided versus two-sided.